Hello there. In this video, Colin Heathfield from Cole-Parmer is going to talk to us all about centrifugal pumps. So, a centrifugal pump, Colin, what is it?
It's a rotational pump. It's complicated in terms of the exact science of it, but the motion, the action isn't too complicated. The centrifugal pumps account for 70% of the pumps currently used within industry or within the globe, around the globe. They are by far the biggest pump market going. They do higher flow rates, lower pressures, and they are a truly pulseless flow rate. Mm-hmm. When we talk about centrifugal pump, the easiest way to think of it is if you think of not the propeller on a boat, but an impeller, so the liquid would come through it rather than off it. It's the throwing the liquid through that and then throwing the liquid out. I will explain more as we actually go on to how it works. But there is many types of centrifugal pumps, and they have end suction ones. This is an end suction. Yeah. This one on the table.
It's a very small one.
It is a very small one. Yeah. It's a lab scale. It fits within the range of what some people will use. Up to the biggest centrifugal pumps. You and I could sit and have this discussion in the casing of the pump.
Okay.
They're vast. You would have people like the water companies use what we call axial flow pumps to move water from the reservoirs to other reservoirs or to the main systems, and these are very large axial flow pumps, very big casings. Other examples, because they're pulseless, is a big advantage. So other examples is things such as borehole pumps. The water that comes up from underground, you drop the pump down into the water and you can move a large quantity of water, and you can increase the pressure by putting more what we call stages of the pump there to bring it up to the surface for us to drink.
Okay.
So they're very much that side that everyone would know, but there's a lot behind the scenes, from shower pumps to chemical pumps, dosing pumps, circulation pumps. There is a high probability. Do you have a heating system?
I do.
You do? You have probably a centrifugal in your pump, in your house, recirculating the water, the hot water, when you have that.
Okay.
If you have a shower, you'll have a centrifugal pump doing that. It's the most common type. That said, there's lots of variants. So if I could talk to you about more detail of it, how it might work.
Yeah.
So this is showing a very specific type of centrifugal pump. It's called an end suction BS4504. That's just a category, but that just says that the inlet is going to be in one place, the outlet is going to be in another place. This is long coupled. If we look at it, there is a red impeller. Can you see the red item?
Yes, I see that, yep.
So that's what we call the impeller. That's what this is. Mm-hmm. And then we have a casing round it. So if I stand back so we can see, that's a volute casing. Very, very critical. It's supposed to be off-centered. So the liquid comes in along the suction side, which we've marked there, into the inside of the impeller, and is then thrown off or up the vanes around the volute casing and out.
Ah, I see.
This action imparts energy to that liquid. So if you take it down to a thinking of the liquid, accelerates along these veins and it imparts this energy, and that is then channeled up here. And you have this area to bring it and increase it, and it moves it out.
Okay.
So anything you do, you're trying to impart energy to the liquid at a very minute scale to give it energy to move out. And it comes out what we call the pressure side. The area, as I say, this is called a volute chamber.
Yeah.
So you have the impeller turning in the volute chamber. This example is putting the liquid through the impeller. Mm-hmm. There is variations and variants whereby you have what we call a recessed impeller. So the impeller would sit slightly back, and you will create a distortion in the liquid in front, and then put that through a volute casing. That allows you to handle solids and soft solids, and other, not abrasives, but particulate matter. The strangest thing I've actually pumped is fish. From where the ship docked, poured them into a large chamber, used water as well, and they went from there to the gutting yards. And so I sold a centrifugal pump, albeit one we call a cantilever, so it's in a different orientation, to pump fish. The principle of operation is quite basic. It's spinning It will spin at a certain speed. It has to spin over a few hundred RPM in order to create this motion. You have the volute, the casing.
Yeah.
You would have what we call a mechanical seal in here.
Yeah.
Because you have a shaft coming off the back, and you have to have something stopping liquid coming from the inside to the out and the outside in.
Okay, where would the mechanical seal be on this diagram?
On this diagram, it will be back. It's fairly close behind where the impeller is.
Okay.
You will have a long shaft going from the impeller through, and you would have a motor behind this unit. We also do close-coupled versions, where the motor is bolted directly onto the pump head, what we call the pump head. But you still have a mechanical seal in them. The reason it's such an engineered solution is, one, you have to pick the mechanical seal for the liquid. Two, these operate on what we call a pump curve. So you have a best efficiency point, so you want to pick it on a more efficient operating point. But they are a very good value, long life pump. One other major thing in picking them as well is we have a thing called NPSH, which is net positive suction head. With these sort of pumps, they can't dry run. They can't really do a suction lift. There is a way of fooling it, but they shouldn't. So you have to make sure that there is enough liquid at, if you would, the mouth or the front of the pump, so that when the pump starts, that liquid goes straight in and there's enough to fill it. So we call that the net positive suction head. That's the suction head to make the pump run, and there has to be enough there to make it happen. So one of our other videos, if you haven't seen it, we actually talk about systems and system conditions. We need to make sure that the suction conditions, so the conditions before the pump, are such that there is enough liquid to keep flowing into the pump. Otherwise, what they do with centrifugal pumps is they'll put the pump in the water. You get submersible versions. You get solids handling versions. They're used on sewage works. But you have to still have that liquid to go into the pump when it starts up. They're very, very good. They can handle the solids with the recessed impeller that I was talking about.
Yeah.
They can handle abrasives. They have many variants in terms of materials. Because material science has come a long way. Traditionally cast iron. You've got cast iron, stainless steel. You can get phosphor bronze for seawater, things like that. They can make them out of plastics now, or plastic coated is the big thing. So they can actually coat the internals in plastics, so they can coat with some of the more aggressive chemicals. They can use other treatments like nitriding treatments to cope with abrasives and things like that. But the big thing is these are a cleaner liquid pump. They can be used for drum emptying. We have another variant called a drum pump, which is a long shaft with the pump at the bottom and the motor at the top. I think large oil cans, 200-litre oil cans or whatever. Yeah. You drop it in and it'll pump everything out of that for you. So they come in lots of shapes and sizes. They are the most engineered, worked-on pump. They do achieve very high flow rates. They can achieve high pressures. I think the highest one I've ever heard of is about 480, 500 bar. That's not within our range, but that's used within the petrochemical industry. Right. So you have to put pump on pump on pump, but you do it all on the same shaft, and then you can drive all the heads and flow them into each other, and you can increase pressure.
And with the different variants, what are the major benefits of use?
One of the best things is the efficiency of use. If you've got to run something 24 hours a day, 7 days a week, you don't want to be using air as a supply because it gets expensive. So you can run them with an electric motor, and you pick, as I say, on this curve, there is the best efficiency point. So it's where you're getting optimum power to the flow rate you're trying to get. And so you pick for best efficiency point. The best efficiency point can be adjusted dependent on the size of the impeller, the size of the hole of the impeller. So the companies that manufacture these have carried out a lot of research into it. So there's different variants with different sizes of impeller. And then you can adjust that to make them your flow rate greater or smaller. Some companies will even trim the impeller for you to make it specifically. Another good thing is they tend to be factory tested, so on the larger ones you'll have things that are already tested before they come out, so they say it already works. Examples of where they've used, I've given a few. I've said they're shower pumps, they're drum pumps, they're on boats, they are everywhere. As I said, within the house, I named a couple of examples.
Yeah.
So it is very, very extensive in what it does. They can handle solids. We discussed some debris in there with the recessed impeller, because you're not then, the recessed impeller only has one side and the vanes on it, so you're not actually putting the product through the impeller, you're putting it through the area in front of the impeller.
Okay.
And that's making a big difference, because then it's not going through. And the process industry, it is by far and above the mainstay of the chemical and process industry. Summarise what I've been saying. High efficiency was something I've defined. Smaller footprint. We mean by smaller footprint, not so much the lab scale side, but when you go to the larger side and the larger scale, when you look at pumps doing bigger flow rates, they have a bigger footprint or ground area that they need to cover. And if you have a plant you're running, your pump, you can have a pump that takes up 2 or 3, 4, 5, 6 meters length of space by a few meters wide. But if you have a pump that you could fit 4 in the same space, you could have a much greater efficiency. So you utilize your space, you lower your cost. It's about overheads. We didn't talk about maintenance. Maintenance is quite difficult. This is one is back to bench and needs someone skilled to actually maintain the pump. You do need to have someone trained in how to change it, how to change the mechanical seal. Mm-hmm. In terms of just chopping and changing them, you can have a duty and a standby pump, and they are fairly easy to swap out and swap in. So there's not difficulty in that respect, because it's undo the connections, take out and put in.
So it's reducing downtime.
Yes. They are truly pulseless, and this is something the other types, a lot of the positive displacement types of pumps we talked about, pulse. Mm-hmm. These are truly pulseless. Because they're truly pulseless, it is that smooth flow. And if you have a process that you're adjusting, that you want to add things to, the smoother the flow, the less adjustment your system has to make, the better your reaction, the better your production. And within industry, continual improvement and continual processing is a big driver these days, especially within the chemical and pharmaceutical industry. So if they have that constant flow, then it's much, much easier for them. And then we look at the applications. Again, we've covered those. We've said clean liquids, we've said dirty liquids, we've said the material variants, and they go to low to very high flow rates. This is your biggest flow pump, and this is what you want to be looking at. And that's a centrifugal for you.
Fantastic. Thank you very much indeed. So that's Colin from Cole-Parmer talking all about centrifugal pumps. If you want any more information, you can contact the team at Cole-Parmer using the details on the website.